This is Whiskey 5 Mike Alpha Echo, Travis County, Aries, Austin, Texas, y'all. In this video, we'll be installing a solder male N-type connector onto LMR 400. We'll begin the process by making sure we have a clean square cut on the coax. The connector comes in two parts, a body and a barrel, and we'll use the body to measure our first cut. You'll notice the center pin on the N-type connector has a thickened region and then a narrower region at the end, and we'll want our center conductor to come to the end of the thickened region. So we'll want to make our first cut about right here. We'll be cutting through the jacket and through the shield braid and into the dielectric below. We don't want to nick the center conductor in this process because RF propagates along the skin of the conductor, and nicking it can significantly degrade the performance of the resulting connector. We'll start by making a shallow cut on the jacket, and then we'll progressively deepen that cut through the shield material. Again, trying not to nick the center conductor. And I'll make a transverse cut along the jacket to facilitate its removal. I'll just peel it up from the side. And the braided shield came off with the jacket. And LMR 400 has a foil shield on the dielectric. We'll remove that by sticking our thumbnail into the cut and twisting to remove the dielectric. Dielectric in LMR 400 is foamed polyethylene, which has a low melting temperature. We'll make a second cut to expose the shield braid. Again, referencing our connector, we'll peel back the jacket, exposing the shield braid from about here. We'll make a very shallow cut in the jacket, really just scoring it. And then a transverse cut to aid in its removal, going a little bit deeper toward the end. And then we'll peel a bit the jacket back from that cut to expose the shield braid. The next step in the prep is to use braid trimmers to trim back the braid. One common fault in connector assemblies is for the shield braid to come unraveled during the installation process, and conductors will get into the dielectric area and may cause a short at some future date. So it's important to give that dielectric area lots of clearance. I want to inspect the dielectric area to make sure that it's free of any conductive material. At this step, I like to apply a little bit of liquid rosin flux. This is optional to the shield braid, just a very light coat, and seal the bottle again afterwards. Liquid rosin flux is flammable, should be kept away from heat and flames. Next optional step is to thread on a piece of heat shrink. This is 1/2 inch double wall heat shrink tubing. And then we'll screw the connector body onto the coax, threading the center pin, the center conductor, through that small hole in the end of the connector by feel. If this was a stranded center conductor, you will want to make sure that the strand is still very tightly woven and circular, otherwise you won't be able to properly insert the body. And we won't apply any pressure in this process. You have to find the center pin by feel, and then we'll screw the body onto the coax. This area of the connector body is threaded and bites into the coax, offering a great deal of structural strength to the connector. This is a handy tool from DX Engineering that makes threading connector bodies much easier, and we'll thread it until it meets some significant resistance and remove the tool. And if we examine the connector, we see braid material through this hole and through the hole on the opposite side, and we can see center conductor in the small hole in the pin. We'll now continuity test it to make sure that we haven't introduced any shorts into the connector. And now we're ready to solder. It's a good idea to continuity test the connector at this point, because your connector is still recoverable if there's a mistake. And once you begin soldering, then you'll need a new connector if something goes wrong. So we'll put our connector in a vise. LMR 400 is very stiff coax, and well, relatively stiff coax anyway, and this operation requires 3 hands. Humans really only have 2 hands to work with, so we definitely need a vise to do this work. I'm going to move the coax to make this easier to do. Get that pin upright. Alright, so there's a small hole here in the center pin, and we'll be soldering that hole. Get a straighten our 22 gauge solder so that we can feed it into that hole, and we'll clean our soldering iron tip. Oxides develop on the hot soldering iron tip, and they need to be cleaned off before soldering to make sure that you don't introduce them into the connection, because the solder won't stick then. Alright. So we'll start by heating the hole with the tip of the soldering iron. We're warming up the center pin body. We want to apply a minimum amount of heat for a minimum amount of time in order to solder this connector, because the Teflon insulator in the connector will melt, and also the dielectric material inside of the coax will melt if it gets too hot. We'll hold this here for about 8 seconds or so, and then I'll move the soldering iron to the side and feed solder into the hole. And when the connector is hot enough, the solder will wick into that hole. And oftentimes, it's hard not to get at least a little bit of solder on the pin. So we'll take some super wick and remove the excess solder from the pin. by swiping the super wick between the unwanted solder and the soldering iron. We'll continuity test again to make sure that our soldering did not introduce a short. And then we'll solder the holes in the connector body. Get that hole fairly vertical. In our vise, normally we'd use a larger vise, but since I'm videotaping this, I need a smaller vise. Clean our connector tip, and we'll hold the tip. This is a 1/4 inch chisel tip. We'll hold it across the hole. The objective here is to heat the body of the connector and not the coax beneath it. If we heat the coax beneath it, we will tend to melt the dielectric material. We'll hold this on here for about 8 to 10 seconds. And then I'll feed solder into the joint in sufficient quantity to fill the hole. And again, we want a minimum amount of heat for a minimum amount of time to avoid the possibility of damaging the coax. Let this cool for a moment. And then we'll switch to the other side and solder the other hole. Clean our tip. Another technique you can use for soldering these holes is to place your soldering iron across the hole, again not down into the hole, and heat the hole for 8 to 10 seconds. And then back the soldering iron off just a bit and feed solder into the hole in sufficient quantity to fill the hole. We'll continuity test again, and we've not introduced any shorts into the connector. Next step is to bring the heat shrink tubing up over the connector body. Connector body is still somewhat hot, and heat shrink, use a heat gun to shrink that tubing. If you look into the body of the barrel, you'll notice there's an O-ring in the N-type connector body, and that weather seals the joint on the connector, and you need to wait until the body cools off sufficiently so that it doesn't damage that O-ring when you apply it. And then you screw the body on and tighten it with a pair of pliers. And that's solder in male connector on LMR 400.